Hello, one and all. Uh, Welcome to my channel. Today we are going to study class 8th chapter, Force and Pressure. Let's start the chapter. Okay, as we said in the name of the chapter, Force and Pressure. Okay, so we are going to study about the force. What is force? A push or pull is known as force. Whether we are pushing any object or whether we are pulling any object, the object will move or the moving object will be in state. So the what force do? Force change the state of any object or state of motion of any object. If the object is moving, it is going to be at rest, and if any object is at rest, it is going to move, right? Let's explore some more properties of force. Okay, so force is a quantity which have two things: magnitude. Now the question arises, what is magnitude? The amount of force is known as the magnitude. For example, let's have uh, the dimension of the length of this particular bar is 5 centimeter. Okay, so here 5 is going to be magnitude, right? So here if I say I am applying a force F1 of 5 Newton, so here 5 is known as the magnitude of this force. But if I am saying that I am applying this 5 Newton force in this particular direction, so now this force is having magnitude as well as direction. So force is a vector quantity which is having magnitude as well as direction. Okay. For example, here I am having two blocks. I am going to apply the force on these two blocks. Suppose F1 amount of force I am applying from this particular direction, and again I am applying one more force of F2 amount in the same direction. So this both the direction are going to add up, and the total force on the block is going to be F1 plus F2. This case will be there when the force are having the same direction. Now the question arises that what will happen if the force are not applied in the same direction? So here let's see, here I am having a block. Again, F1 amount of force I am applying from this direction, whether the F2 amount of force I am applying from another direction. Here you can clearly see that both the forces are having different directions. Okay, so here I can say that my F1 and F2 are in opposite direction, so I can convert this. This is my F1, but this is my F2, right? So I can also write it like this. This is my F1. Now I will change the direction of F2, but I will apply a negative sign over here. Now again I am going to add these two forces. So my total force is going to be F1 plus negative of F2. So my total force is going to be F1, sorry, this is not will be positive, plus and minus give us minus F2. So my force, total force on this particular box on at which we are having the forces with opposite directions. So the force, total force will be, total force is going to be F1 minus F2. Now the question arises that in which direction this block is going to move, right? If F1 is having more magnitude than F2, then the block is going to move in F1's direction. Whereas if F2 is going to be more than F1, then the block is going to move in F2 force direction, right? But one more case is there. What will happen when your both the force are having same magnitude? Here I am talking about magnitude, no direction. Then the object is not going to move. No motion will be there, right? So when the forces are from opposite direction, the object is going to move towards the force which is having greater magnitude, right? Now let's move to the topic that is some properties of the forces, right? When we apply a force on any object, it changes some properties of that object. It can change the speed, it can change the shape of that particular object, it can also change the direction of object, right? Let's start with the speed. Okay, this car is initially at rest. Initially at rest means its initial velocity is 0. Now these two girls are there. These two girls are applying some force. This girl is applying F1 force and this girl is applying F2 force. Now what will happen? This car will move. Okay, so this car's velocity is going to be some quantity, suppose x meter per second, right? So here you can see that when I am applying a force on this particular car, its speed is going to be changed, right? Next, force also can change the shape of object. Here I am having a spring, a rod and a can. I am applying the force on these three objects by different types. Here I am going to stretch a spring. Okay, when I am going to stretch a spring, the shape of the spring is going to change, right? Now again I am having a rod. If I am going to apply a pressure on this particular rod from both the direction, what will happen? I can apply like this or like this. In both the cases, the shape of the rod is going to change. Here in diagram, we can clearly see this, that the shape of the object is getting changed. Next, we can say that here I am having a can and I am going to crush this can with the help of a hammer. What will happen? The shape of the can is going to be changed. Here you can see this. Okay, now let's move towards the type of the forces. There are two types of force on the basis of what type of contact they have with the object. Here I am having contact force and non-contact force. When both the object and the source which is applying the force are in contact, that time the force is known as contact force. When if the object is not in contact with the source which is applying the force, that is known as non-contact force. Further, we will study in detail about both the forces. Here I am having contact force, right? Contact force, that means both the source and the object on which we are applying the force are in contact. Here I am having two examples. First one is muscular force and another one is frictional force. Now let's see what is your muscular force. The force exerted due to the action of muscles in a body, right? Here for example, I had taken a bullock cart. Here I am having a bull, right? A muscular animal. The muscles of the bull are applying force to pull this cart in this direction, right? So here, what is applying the force? The muscular action of the bull. What they are doing? They are moving this cart along the bull, right? So in this object which is moving and the source which is applying the force are in contact with each other. So this is a contact force known as muscular force. Another one is frictional force. Frictional force we can explain as when two objects are in contact and they are moving, right? This hand is stationary and this hand is moving, right? So one force will get generated which is going to be in opposite direction of the applied force. I am moving this particular hand in this direction. The frictional force will start acting in this particular direction, right? And this oppose the direction of motion, or we can say the frictional force restrict the relative motion, right? For example, here I had taken a surface which is little bit rough over here and a box is sliding on this. The person is applying a force Fa in this particular direction. So the frictional force which will get developed between this block and this surface, and that is going to be in opposite direction to that particular applied force. Okay, it is a restrictive force. Next we are having non-contact force. Non-contact. By name we can say that both the objects are not in contact. Here I am having three examples of non-contact force: gravitational force, electrostatic force, and magnetic force. I had also selected three different type of example to explain them, right? By the name non-contact. If an apple is freely falling under the gravity of our earth, what force will going to act on this particular apple? Force due to gravity of the earth, right? Okay, so what will happen? The gravity of earth is going to pull the apple towards him. That means an attractive force will be there, right? This apple is going to fall just because of gravity of earth. This apple and earth are not in contact, so again non-contact force. Now I am having a balloon. Okay, I had taken a balloon, I had rubbed the balloon on my hands or on any woolen surface. What will happen? The balloon will get charged, right? Now I am going to take this balloon towards tiny piece of papers. What will happen? That piece of paper are going to attract towards that charged balloon. This is happening due to electrostatic force, which actually act between two different type of charges, right? Whether they can, if the charges are similar, the action is going to be repulsive. If the charges are opposite, the action is going to be attractive. Again, the piece of the paper and balloon are not in contact. So this is an example of non-contact force. Another one is magnet. Okay, what a magnet do? It attract material which are of iron, right? Here I am having some iron nails that are kept over here, and I am having magnet that I am taking towards this particular nails. What will happen? This magnet is going to attract that nails. Again, they are not in contact, but a force is acting between them, non-contact force, and this type of force is known as magnetic force, arise due to magnet. So this is all about force, its properties and its type. Okay, in our next video we are going to learn about pressure, what pressure is, what are the effects, and what are the impact of the pressure. Thanks for watching. Have a nice day.